and the bottom of the chassis, mainly just to hold everything in and also to stop attacks coming from over top. Version 2 used Garolite G10, which is this stuff. It's very strong, very good at impact resistance. It's like a fiberglass epoxy resin type stuff. This is very similar to like what's used in a PCB material. The version 3 uses ABS, which is a very common plastic. It is very flexible and it's significantly lighter. This stuff is also a lot easier to cut. I can throw this down on my laser cutter, hit a button, and boom, it's cut. So this is a lot easier to prototype with as well. But since there is a plate on the top and the bottom, the little bit of weight savings that I got from using ABS was relatively substantial. I want to say it was like 20 or 30 grams over going with something like Garolite, so that allowed me extra weight to be put elsewhere in this robot. The other thing is, there's just not that many overhead hammer robots or overhead spike robots, so I'm really not that concerned about, actual impact on the top or the bottom of the robot. So I went with just the ABS because I'm just not that concerned about that type of damage, and I'd rather have the weight than the impact strength. Before I talk about the weapon differences between these, I wanted to talk about the wheels. On all previous generations of Sergeant Cuddles, I was using these Pololu wheels. They're really lightweight, really cheap, they're simple, they just press on, and they actually have surprisingly good traction. The only problem is when you slide sideways, the tread comes right off and then it gets jammed in the robot, which is not good at all. And this almost cost me a fight, so I decided to change away from these wheels. I decided to try out these foam wheels from Fingertech Robotics. They're these nice little foam wheels, and they have this aluminum hub that the wheel just kind of slides on like that, and then this other piece clamps on the other side. The problem I had with these was that the bore was just way too big. This was supposed to be a 3mm to fit the 3mm shaft, but as you can see, there's a ton of play in there, and even with the set screw, they're basically just gonna wobble like that. So I had to go through 3 different sets of bores to find one that was acceptable, that would run true, and even still, I had way too much wobble in the wheel. Additionally, I had a lot of these that were either cupped or kind of trapezoidal like this one, to where there's a definite angle to where it's only making contact right there. And lastly, this material just provided no traction on the arena that we were at. The arena was just a sheet of steel that was unpainted, uncoated, and these just had no traction. So by the end of the tournament, I actually swapped these out for the Pololu wheels instead, and actually got traction, was able to drive around. So I'm gonna ditch these for something else. Right now I'm looking at using these Banebot wheels, which have this aluminum hub, very similar to the Fingertech, but the bore is much nicer. There's really no play on the bore, unlike the Fingertech bore, which is just really way too big. And the wheel itself is a lot slimmer, which is nice, so I don't have to go with these excessively large wheel openings. And then because it has this polyurethane tire, it has a lot better traction for a lot different environments and floor types. So I'm gonna try going to these. The only reason I didn't do these initially is because they're a lot heavier than the Fingertech wheels, and just, ever so slightly bigger. So next iteration is gonna end up using these. The final and probably most obvious difference between version 2 and version 3 is the weapon itself. For version 2, I'm using an aluminum drum with weapon teeth. They're made out of just stainless steel screws. And for version 3, I'm using a solid grade 5 titanium bar. They're very similar in concept, but they perform a little bit differently. So let's kind of disassemble these and show you the differences up close. Here are the 2 weapons removed from the chassis. We've got the original aluminum version 1 and 2 here, and then here is the version 3 out of titanium. So the original one was made out of 6061 aluminum, and if you're not familiar with all the different alloys, don't worry, neither am I, but 6061 is a relatively soft alloy. There's 7075 and 2021, I think, are the other 2 primary alloys used in robotics. 6061 is going to be the softest of the bunch, and that is good because it will take a lot of impact and it will just kind of dent and chip away like this, and it won't actually shatter like a 7075 would, because that's a lot more brittle. So most of the damage is actually going into these screw heads, and you can see this one's actually bent over quite a bit. These are just stainless steel screws, so these are actually pretty darn strong. So you can see the kind of impact that is absorbed by these. And this drum was all turned on a lathe, and then these flats were machined, so it's a relatively simple design. A lot of people are doing a design like this. For the version 3 drum, this is grade 5 titanium, which is a much harder material than the 6061. It is a little bit heavier in terms of density. However, both of these actually weigh the same amount. This one is a lot more solid throughout, where this one has a lot more opening. So even though this one's a lot bigger and the titanium is denser than the 6061 aluminum, they're about the same weight. I think it's like a gram or 2 difference. They're almost identical. Other than that, they're pretty similar. This one is going to be more of an egg beater. I don't think most people would call this a drum because traditionally drums, well, look a little bit more like that. So this is kind of more of an egg beater design. And one of the reasons I went to a design like this is because with the old drum, I kind of had an issue actually making contact with opponents. If you really look at this, I only really have a contact area from here to here. So that's the only place I can really make contact. This really won't ever make contact, and there's nothing over here. Whereas with this one, I have this long flat that spans the entire length of the weapon, and so if you look at it like that, it really is effectively double the contact area. So this one, as long as you're coming at the robot somewhere from the front, it's probably going to make contact with this. This also acts as an armor. If you look at some of these dents and some of these scrapes on it, this absorbs a lot of impact that would otherwise go into a portion of the chassis. So having this across the front is a good plate of armor as well. In terms of how these mount inside the chassis, they both mount pretty much the same way. In one side you have a large recess, that is where the Outrunner motor gets press fit inside, and they both use the exact same motor. And on the other side, they both have a recess or pocket for a standard skate bearing that just slides inside like that. So once the motor is snapped on one side, and then the bearing is put on the other side, you have a spinning weapon like that. Both of them use just a simple plastic washer that kind of sits between the frame and the bearing, and then there is just a screw that acts as the shaft on the other side. Now there's a slight difference in the shafts. On one of them I use this countersink head screw, and unfortunately cutting the profile for this in the UHMW is really tricky. You can use just a standard countersink, but very few of them are sharp enough to get a good cut. So ultimately it ends up looking something like this. It just kind of chews away at it. So this doesn't really sit as flush as I might like in there, and you can see it doesn't really screw in perfectly straight either. So I really wasn't happy with how this ultimately went. So for the new version, I went with this socket head cap screw that I end up turning down on the lathe. So this started out as a standard socket head cap screw that was a lot taller. I cut it flush, so it has a relatively thin profile head, and then this is largely hollow through the inside to save weight. And this has a much different and easier to machine profile, and so when this is screwed in, it actually sits perfectly flush with the side of the chassis, and it's pretty much guaranteed that it's going to sit straight as well. So this was just a lot better version of how to do it, and I like this a lot better. It just kind of looks pretty slick too. I decided to make a specific video just for the machining of the weapon because this was the first time I was dealing with a part this complicated.